Hi and welcome back to another new video of Basics of Electrical and Electronics Engineering, which is a subject for first year K2 syllabus students. So today we are going to discuss what is the average value, RMS value, peak factor, form factor of a sawtooth waveform as shown in figure. A sawtooth waveform as shown in figure. So what is a sawtooth waveform? So it is given, the figure is already given to you. So this is a sawtooth waveform. Okay, this is a slanting line and this one is straight line. Okay, so this waveform is known as a sawtooth waveform. We are going to find what is the average value, RMS value of these waveforms. Okay, for this also we are having two methods. One is the standard method and the second one we can call as an easy method. Okay, so what is the standard method, how to calculate it? First we are going to do average value. We are going to find what is the average value. Here it is a voltage waveform. E means a voltage waveform. Okay, and the maximum value it is attaining is Em and this point value is T. Okay, now we are going to find what is the average value. Average value is equal to area under the curve for one cycle divided by time period for one cycle. So what is the area under here I have mentioned a squared wave. It is not squared wave. Area under the wave for one cycle divided by time period for one cycle. How can we find the area of one cycle? Using the integration method, you can see this is the line and we are going to find the area from 0 till t. We are going to find the area from 0 till t. So how can we find? Integrating the area of a small strip. What is the area of this small strip? We have to find out what is the area of the small strip. The length we can consider as instantaneous value which is changing and breadth we can consider as dt, isn't it? So your area of one strip becomes. So how can we find the, okay, as we already mentioned, the length of the strip is small letter e and breadth of the strip is dt. What is this equation for E? Is it E is equal to Em sin theta? No. It comes only when the wave is a sine wave. Here it is not a sine wave, it is a straight line here. So don't write the equation for E as E is equal to Em sin theta and you have to do the problem like that. Then it will be completely wrong. So what you have to do? We have to write the equation for small letter E. What is the equation for E? E is equal to, it is a straight line. The equation for a straight line we have studied as y is equal to mx plus c. The same equation we are going to use here. So for E also we are going to write the expression as E is equal to mx plus c, where m is the slope of this line. So what is the slope of this line? Delta y by delta x. What is delta y? Em divided by, what is delta x here? T. So our m value becomes Em by t. So I have written it here, Em by t, that is the slope. Now instead of x, what we have to write here? X axis here is t. So instead of x we are going to write as t. Now what is c? C means the y intercept, which means, for example, if you are starting from here, then this is known as the y intercept. Here it is starting from 0 itself, so the y intercept or the c value is equal to 0 here. So our total equation becomes E is equal to Em divided by t into small letter t plus 0. Okay, so our equation we are going to substitute it here. See, E is equal to mx plus c, m is Em by t into small letter t plus 0, which means here there is nothing. So this is our equation for E now. We are substituting it here and finding what is the answer. So Em by t into small letter t, integrating it, constants are taken outside, whole divided by t is there, don't forget that one, that is the time period for one cycle. Integrating from 0 to capital T, t dt, t is t square by 2 in the interval 0 to capital letter T, Em divided by t square by 2. Putting the limits, you will be getting the expression like this and we are getting the final answer as Em by 2. t square and t square will be cancelled out. So this is the average value of this sawtooth waveform. Next we are going to find what is the area under the RMS value. Root of area under the squared waveform for one cycle divided by time period for one cycle. So we have to square this waveform. Do you know what will be the waveform or shape of the waveform when we are squaring the straight line? See, it will be just like this. Okay, and we don't know how to find the area under this curve. So again we are going to use the integration method where we are going to take the area for a small strip and we are going to integrate it. So what is the equation? Integrating from 0 to t, e square dt divided by capital letter T. What is small letter e? Small letter e is em by t into small letter t. We have already wrote the equation for that. Substituting the values there, you are getting the expression like this. Now we are going to take the constants outside. Okay, so constants are taken outside and the remaining terms are t cube by 3 in the interval 0 to capital letter T, and em square divided by t cube into t cube minus 0, putting the limits. You will be getting the answer as em by root 3. So this is your RMS value. Next we are going to find what is the peak factor and form factor. Peak factor is peak value by RMS value, form factor is RMS by average value. Substituting the values, you will be getting the answers like this. Now we have done the problem using the integration method to find the area. But next we can go through how can we calculate this in an easier way, that is using the standard area equation. Okay, so we are going into the waveform first. Now we are going to find what is the average value by taking area under the curve for one cycle by time period for one cycle. What is the time period for one cycle? It is from 0 to t. So t. What is the area for one cycle? Here you can see it is a triangle. What is the area of a triangle? Half BH. So that is why I have written here as half BH. What is the base here? Half base is t and altitude is em. Substituting the values there, we can easily find out what is the average value. See, very easy to calculate as we know the general equation for finding the area for a triangle. Next one, we are going to find what is the RMS value. RMS value is equal to root of area under the squared curve for one cycle divided by time period for one cycle. So what is the equation? There is a general equation which we can use for finding the area under the squared triangle. Okay, triangle, a wave when it is being, or a straight line when it is being squared, a waveform we are getting, and there is a general equation for finding the area of this waveform, that is 1 by 3 bh square. So we are going to find what is 1 by 3 bh square, where base is t and h is em. So just putting the values there using the direct equation, we can easily find out what is the answer for RMS value. Here no integration steps are there. Direct equation is being used for finding the area. Next we are going to find what is the form factor and peak factor. Form factor is RMS value by average value and peak factor is peak value divided by RMS value. You will be getting the answers like this. So by both methods you will be getting the answer same. So you can use any method. Standard method can be generally used, or if you are not thorough with integration steps, you can go for the easy method. So thank you everyone for listening. Study well. Stay tuned for the next video. Bye.